you're told that BQ over OC is 3 over 5. Now, the moment you see ratios, what must come into your mind is the concept of the constant to make it easier for you to do the question. Okay? So, BQ over OC is 3 over 5 and BR over RA is 1 over 2. Okay? Then the question says if BT is equal to K, calculate TQ in terms of K. Okay? It's not difficult, it's very, very easy. It's very, very easy. As long as I'm your teacher, it's very, very easy. Okay? So if BT is equal to K, okay, that's BT then, equal to K. Which means along BC, our constant that we are going to use is going to be what? K. So let's deal with this ratio and that ratio. Now BQ, okay, BQ is 3 over 5, right? BQ over OC is 3 over 5. What that means is I can call this one 5 what? K. 5K. It's very easy. Very, very easy. Okay? Then, so OC is 5K, then means BQ is going to be what? 3K. So this is going to be 2K. Alright? So, if BT is going to be K, calculate TQ. Right? Now, to calculate TQ based on the information that's there, means we might probably need to use our proportion what? Theorem. Okay? We can use the proportion theorem. Now, what are the information are we given? We are given BR. Okay, this is the answer, but I'm gonna, because it's 3 marks. You cannot just write 2K, then expect to get 3 marks. But I know what the answer is. So I'm gonna do a proper working out. You understand? Right? We are also given this ratio. It says BR over RA is equal to what? 1:2. Okay? So I'm going to use a different constant now. Let me use Y. So BR over RA. So this one I can call it Y. That one I can call it what? 2Y. Then I'm going to apply the proportion theorem in triangle ABQ so that I can determine the length of TQ properly. Okay? But I know what the answer is. So I'll say in triangle A, B, C. Okay? Sorry, it's ABQ. ABQ. Okay? Do you see that TR is parallel to AQ? Do you see that? Yes. So I can use the proportion theorem. So I can say, since I want to calculate TQ, I can say TQ over BT is going to be equal to AR over BR. Then give the reason line parallel to one side of triangle. Okay? Now this is exciting, you see just now. So TQ over BT. Now BT we are told that it's equal to K. AR, we are given this ratio of BR over RA. But I wrote the length in terms of what? Of the constant. So AR, what is AR? It's what? 2Y. What is BR? It's Y. Okay? Then, I'm sure you can agree with me that this constant cancels with that. Is that making sense? Yes. Then, if that happens, we'll end up having TQ over K is equal to 2 over what? 1. I use the proportion theorem. Then you cross what? Multiply. So we can say, therefore, TQ is going to be equal to 1 times TQ is TQ, K times 2 is 2K. Are you following? That was in the diagram. I was explaining in the diagram. But for you to get 3 marks, remember there is a mark allocation of what? 3. You can't just get 3 by writing TQ is equal to 2K. No, you get 1 mark out of 3. How did you get the answer? That's the way it came out. Hey, listen, are you following? Are you following? Please, I don't want to see anybody in the near future. If you see a question on proportion theorem and then you leave it blank. Why? It shouldn't be. Why? As long as Mr. Chiponda is your maths teacher, you cannot leave a question on the proportion theorem from now on blank. Yes. Yes. Circles are also part of your generally, most of the time the proportion theorem is tested on its own. But there are times when it can also be incorporated into a circle as well. Okay? But listen, your circle geometry is in your match test. You're supposed to go over. Right? Remember, I told you that the match test is for grade 11 work and grade 12. That's how it works when you're in metric. Okay? Alright, let's move on to the next one. Then the next question, can I have your attention? Now, I just need to add the information that I have so far. I said this is 5, isn't it? So that's 5K. So this is 5K over that's 2Y and that's 1. Alright, can I have your attention? Please pay attention. The next question says, hence or otherwise calculate the numerical value of CP over PR. Right? Where is our CP? Okay, let's locate it. Alright? C is here, P is there. That's CP. Alright? Please look on the board. Look on the board. Right? PR, so we have got our R here, and then we have got PR is from here up to there. So we need that ratio. It's very simple. I'm sure you can see what the answer is. Yes. What will be the answer? Based on the information that I have here, everything that I have been saying, the answer for this ratio is there. It's there on the diagram. It's a ratio. It will be 5 over what? 5 over 3 or 5 over 2? There's no n here. Listen, Tando, I said, based on the information that's here, the answer is there. So don't bring in n. Yes. Yes. So now be 5 over 2. Thank you. So if you look at which triangle can we apply the proportion theorem here? Huh? It will be CRT. No, it's not necessary here. For this question, it's not necessary. So we'll say in triangle CRT. Okay? In triangle CRT. Since we want the ratio of CP over PR, we'll write here CP over PR. CP over PR is going to be equal to what? Yes, thank you. So it's going to be CQ over TQ. Then you write your reason. Okay? Now, it's very easy because I know what the length of CQ is in terms of K. I know the length of TQ in terms of K. So you can start smiling. So this will be CP over PR. It's going to be 5K over 2K. The answer will be 5 over 2. And then you are done. Then you are done.
So basically, like let's say maybe you know the answer, but like maybe you don't have to use the answer, just like answer what you get.
You get 1 mark. At least you get 1 mark. Alright. Please, can you stop that?
But there's something other than just five.
All right, let's move on. Now we are going to do 8.22. Hey, 8.22, please pay attention because we have not done a question which requires the concept that I'm going to talk about now. Can you pay attention, please? Pay attention. So far, I have told you that the ratios of areas of triangles can be determined by using the formula half base times height, also the sine rule, all right? So the area rule rather. It can also be determined using similar triangles. But at the moment, we haven't done similar triangles. But I'll talk about that next week. Furthermore, it can also be calculated by identifying three triangles such that one of the three shares a common height with the other two. Okay? Now, that concept is the one that you require to do this question. So, let's identify our two triangles and see. So, we have got triangle RCT. So, this is RCT. Okay? That's RCT. Then, we have triangle ABC. This is the big one. Okay? Okay? That's ABC. Now, based on everything we have done so far, do those two triangles share a common height? Do they share a common angle? No. Check no. Though they share a common vertex here, but they don't share a common angle. Which means, number one, they don't share a common height. Also, their bases, okay, they are not on the same straight line. So they don't have a common. Now, in that case, it becomes complex. So what you do, you look at one of them. You have to identify one of the two. If one of these two triangles shares a common height with another triangle. Okay? So let's do it now quickly before we go. Okay. Okay, I'm gonna try and write the ratio probably. If I don't finish then I'll carry on Monday. Alright, can I have your attention? Please pay attention. So this is 8.22. Now, is there a triangle? Please can you pay attention? Is there a triangle that shares a common height with triangle ABC?
Yes, there's two, AQC and
AQC
AQB.
and
QB.
AQB. Is there another one? Wait. That triangle must also share a common height with RCT. Which triangle shares a common height with both these two triangles?
Wouldn't it be
ABQ. ABQ doesn't share a common height with RCT.
RTC? I had a triangle though.
No. Which triangle shares a common height with both triangle ABC and triangle RCT?
So we don't know. It's
No, look at the diagram. Why would you give up so? Why would you give up so quickly? It will be what? ABQ.
Yeah, you can't say
No.
it's with
Listen, ABQ. Can I have your attention? ABQ does not share a common height with RCT. It will be what?
What
It will be
about
RBC. Thank you. It's RBC. Thank you, Bongisa. Okay.
No. How?
You don't say
But we did say it, so.
you don't say that.
I thought she said
No,
RBC.
she
don't say
did.
that.
But someone actually did say it.
There's a voice that I had
It
saying
says
RBC.
It was me.
All right, thank you.
But just.
All right, look here, look here. If you look at RBC, this is RBC. That's RBC. Do you see that RCT and RBC, they share a common vertex here? And can you stop talking and look there? Stop talking and look. RCT and RBC, they share a common height because there is a common vertex here, right? Also, point B, point T, and point C are on the same what? Straight line.
No,
Okay? Wait. Remember, I told you that there are two conditions that must be satisfied for two triangles to have the same height. They must share a common vertex. Also, the points along their bases must be on the same what? Same straight line. So, they share a common vertex here, and point B, point T, and point C are collinear. Therefore, you can draw a height from here going down that way, and it will be perpendicular to their bases.
So that's gonna be practically the height.
Yes.
But could it
Please,
be?
the height is not RT, please. You have to construct a line which is perpendicular to BC. From what? From point R. That line, okay, don't worry about its construction. Okay, the key concepts are the two triangles share a common vertex. Point B, point T, and point C are collinear. Therefore, the two triangles share a common what? A common height.
So, would it be wrong if you were like R, B, T, also shape R,
RBT.
yeah.
It shares a common height with RTC.
Yeah.
That's correct. But RBT does not share a common height with ABC. We want a triangle that shares a common height with both of them. Okay, so are you following? Are you following? Hey, can I have your attention? Then, how is RBC related to ABC? Now, they share a common vertex here. I still don't understand. Okay, it's the best one. All right, I've got another class for you. Hey, wait. Can you clear your desk quickly? Yes, I'm aware of that. You must tell me when you are ready. Alright, then can you stop talking for a few seconds? Can you be silent? Of course, can you be silent, please? Right, good morning, everyone. Alright, listen, before we go any further, you need to check out your network book. I want to see the homework that I sent yesterday. You try this one. Last question.
Stop trying to make me
Remember what I said yesterday, you can't do the same one. So you probably use another one. Therefore, minus C can't be A. Let's use a constant. We're supposed to use a second constant. As long as the size of the triangle is the same, use a different constant. Okay, you see when I use a
No, I
many times. Right? Don't give up. Geometry That's why I went forward.
Like 3 times time. There's one today exam.
I will always give excuses. I hope on the 1st of March you'll be giving excuses.
No, sir, I'm not.
I hope so. Huh?
I'm not taking about homework.
What about, did you do the homework?
But I'm just saying, so someone took my eraser.
You want a new eraser? I can give you a good
So do you have it?
Yeah, I've got extra erasers. Learners, sometimes they leave things they don't come, they can take.
I think this is nice.
Can I have your attention? Can I have your attention, please? Can I have your attention? Alright, it's very unfortunate that some of you are not doing work. Okay? And yesterday's lesson, I spoke about many key concepts on the proportion theory, which I expected you to go home and apply to do that question. Except the last question. Last question was very challenging, right? I never spoke about how to deal with that, but I also expect you to apply and think. Okay. All right. So yesterday I stopped here. The calculation of AW using the midpoint theorem. Okay, this is where I stopped. Now I just want to emphasize to you that 2.2.1 is a grade 10 question. Okay, 2.2.1 is a grade 10 question because that's the midpoint theorem. I cannot accept you here. But it's up to my lesson. Go and you talk to him. Okay. All right. Can I have your attention? Can I have your attention? Okay. Before I carry on, I just want to let you know, if you have got an intention of getting a very good mark in your March test, you have to know your geometry. You have to know it. Okay? You have to know it. For those of you who are playing around, it's a recipe for disaster. Okay? If you are playing around, it's a recipe for disaster. On the 1st of March, you're going to have major problems. Alright? Okay, so let me carry on. Now, yesterday, I was explaining that in order to determine the length of VR, okay, we needed to identify a triangle that we can apply the proportion theorem in. Okay? Now, based on the proof which I did, I think it was Monday or Tuesday, I did the proof of the proportion theorem, then I spoke about the 4 corollaries. Right? Sometimes you may need one of those corollaries to be able to do a question. So here, to calculate the length of VR, just to remind you, hopefully you came to the lesson, you are ready. Right? This is point B, that's point R. Okay? So the triangle that I identified was TSR. That's why I wrote here in triangle TSR. Okay? This is where I stopped yesterday. Okay? Now in that triangle, if I want to calculate the length of VR given the length of SR, I have to use one of the corollaries. So I'll say VR, okay, over SR is going to be equal to WR over TR. Okay, that's also the proportion theorem. So we move on here. I wrote the ratio VR over SR is equal to WR over TR. Then I gave the reason. The reason is obviously based on the proportion theorem. Okay, and I'm going to repeat it again. It's up to you. You can also write proportion theorem and then state the lines that are parallel. But if you write this reason, you don't have to state the lines. Okay, that's why I like it. Because over the years, I've seen that when learners write proportion theorem, some learners forget to state the lines that are parallel, so you get 0 in that case. So VR, okay, is the one you want to calculate, and then we are given SR is 36, given WR, we know based on the constant Y that WR is equal to 7Y, and TR is going to be 2Y plus 7Y, which is 9Y. Okay? Therefore, this Y here and that Y will cancel out. That's the good thing about working with the constant, because in the end, the constants cancel out. So, you cancel out there, then the rest is great. 9-way, solving an equation. So VR is going to be 28 centimeters. Okay. So if you do it the way that I have here, you're guaranteed of your full marks and you'll be smiling. Okay. Any questions? Any questions? I want to be honest with you. Some of you, I don't like the way you are conducting yourself with regard to not doing work. For a matric learner, that's very shameful. Okay? Because there's an iron there. If a person wants to pass with a good mark, you have to show that you really want to pass with a good mark. Okay? Now the next question, right? It was asking us to determine the ratio of the area of PSR over WBR. So PSR, one which I drew in green, and then WBR. What do you notice about those two triangles? Okay, they share a common vertex, therefore a common angle. Is there anything else? Do they have a common height? They have a common height. Well, I don't expect anybody to be confused about that question. Okay? Do they share a common height? No. Okay? Alright, so listen. I think I told you that for two triangles to share a common height, right? The first scenario is that they must share a common vertex. Also, the points along their bases must be on the same what? Straight line. So if you choose a base for any one of the two, you never have the points along that base for both triangles being on the same straight line. Okay? You never have that. So for this question here, you cannot use the fact that the triangles share a common vertex, therefore they have a common height. No. But the good thing is there's a common angle. Therefore, we can use the area rule from grade 11 to determine the areas. Okay? We can use the area rule from grade 11. So, if I want to calculate the area of PSR, it's going to be half times PR times SR times sine R, because angle R is the common angle. Okay? That's the common angle for both of them. The area of WVR is going to be half times WR times VR times sine R. Now, the problem comes if you don't know your area rule, then you have issues. Okay? You have to know your area rule very well. Okay? Just to do a recap, this angle R here, it is formed by PR and SR. Also, this angle R here is formed by WR and VR. Okay? The two sides that form the angle must be in the area rule formula. Right? If you've got issues with using the area rule, then some of these questions will give you a hard time. Okay, then after this now, the half and the half cancel, the sine R and the sine R cancel out. Then you left with PR, SR, WR, VR. The good thing is, if I had my diagram in terms of the constants, it's going to be a piece of cake. So when you substitute for PR, it's 14y, SR is 9n, okay? WR is 7y, VR is 7n, okay? Now, because of multiplication, this n and that n cancel out, the y and the y cancel out. So the constant will disappear. We're left with the integers. So you end up having 14 times 9 over 7 times 7, which in my case, because I don't teach you the calculators, 7 is a factor of 14, so I said 14. So 14 divided by 7 is a 2. So I'll be left in the numerator with 2 times 9, which is 18 over 7. So that will be the ratio of the two areas. Right? I hope you are following. Any question? Yeah, because if you try the question out and you couldn't do it, this is your opportunity to ask. Okay, no one is asking, then let's carry on to the next one. Then I gave you homework yesterday. The reason why I sent you the homework, probably, maybe a little bit late, because I got extremely busy, okay, to a point where I couldn't send it earlier. But I made an effort, okay, just to identify a question to give you and then send it to you. So you have to appreciate that. Right? Otherwise, I was not going to be able to give you any homework. I wanted to give you a question which is not in your textbook, so that you apply what I was talking about yesterday. Right. So in question 8 here, you are told that AQ is parallel to RT, all right? And BQ over OC is 3 over 5, BR over RA is a half. Okay, so the first question was to calculate BT in terms of K. Now, so for this question, they gave you a constant K. So that constant is going to be used throughout along BC. Okay? But now, the mark allocation is 3. Okay? The mark allocation is 3. So you may have to show some steps. The mark allocation must guide you as to how many steps you are likely to need in order for you to get full marks. So here, you must deal with the ratios as well, the ratios that are given. So, first thing that I did, remember I told that when you write a geometry exam, you are given a diagram sheet separate from the question. So you get two diagrams for the same problem, right? The second one is for you to write whatever you like there in terms of solving that question, right? So even for your match test, I gave you a diagram, so you can write things on them. So here, BT is equal to K, okay, that's straightforward. Then we are given this ratio here, 3 over 5. Since BQ is from here to there, and already I'm given BT as K, it means that BQ is going to be 3K, okay? That's basic algebra, okay? BQ is going to be 3K, therefore TQ is going to be 2K. By doing that, I already have the answer for TQ, okay? Right? Then OC is going to be 5K, because BC, actually point B, point T, Q, and C, they are collinear, so I must use the same constant along BC. So that constant is K over C. So your OC is going to be 5K. Okay? I now know the answer, but I need now to write it down properly so that I can get the full marks that are 3 marks. So what you do then, okay, before we move on, we need to deal with that ratio as well. Okay, BR over RA is 1 over 2. So this is BR, that's RA. Okay? Since the ratio is 1 over 2, it means my BR is going to be Y and my AR is going to be 2Y. Please take note, you can use any other letters that you like, as long as they are different from K. Okay? Thank you so much. Thank you. All right. Okay, let's get on. Let's get on. So I'm saying it's your choice in terms of which constant you want to use. So I used Y. If you use a different constant, it's fine. Right. Now I've dealt with the ratios. I've dealt with BT being equal to K. Now I need to write down the working out. So based on this diagram here, you should be able to see that TR is parallel to AQ. Actually, that's given as well, right? So the triangle that I'm going to apply the proportion theorem in is going to be ABQ. Okay, remember I told that if you want to use the proportion theorem, first identify the triangle. If you can't see the triangle, you are going to have major issues. And that triangle must have a line which is parallel to one of its 3 sides. So ABQ, then from there, TQ over BT is equal to AR over BR. Then you state your reason. Then you substitute, so we don't calculate TQ, but we know that BT is K because that's given. And we also know that based on the constant Y, AR is 2Y, BR is Y. But the good thing is that the Y and the Y cancel out. Okay, so we've left 2 over 1, then you simplify that you get the 2 here. Now, if you do this, you are guaranteed of your 3 marks. Okay, you can come out of that exam with confidence and you can tell your friends that I got that question right. Yes?
I just wanted to ask you, yesterday you should go white and
Okay, unfortunately, yesterday you were not here. I just need to let all of you know, and I'm going to repeat this again. The proportion theorem generally is not an easy topic to teach, okay, especially without a memo. Okay, if you are doing it from here, it's not easy to teach. Therefore, over the years, even if you look at some of the past examination questions as well, in metric on the proportion theorem, they also use the concept of a constant. Why? Because it makes things easier to work with ratios. It makes it easier to work with ratios. That's why we have to use the concept of the constant. Okay? It's not easy to teach. I can do the question without using the constant. But the question will be, are the learners understanding what I'm teaching or not? Because as a teacher, I need to make all of you understand what I'm doing. I need to make you understand how to do this question. Okay? So the easiest way is to work or to use the constant.
so every time I get like, okay,
Ratios. Whenever you get ratios, if you use the constants, I can assure you that most of those questions, you get them right. Yes.
I have a question about the correlate.
Yeah?
About the correlate. So it says BP over BA. Is it wrong to flip it around here?
No, it's not wrong. It's fine. Are you following? Sorry. Sorry. Are you following? Okay. So let's get on. We have got time, right? Almost like 20 minutes or so, so I should be able to finish all the questions. Then here, Now we're going to calculate CP over PR. When I was walking around checking your answers, I was actually surprised as to why some of you could not do this question, because it's very easy. If you have put your constants, then you are almost halfway through. Okay? You are almost halfway through. So, for this question to calculate CP, first you need to go to the diagram and identify where CP is. CP is from here to there. And then PR is from here to there. And then you can see that PQ is parallel to RT. Therefore, you can use the proportion theorem in triangle RCT. Okay? Yeah, I'm going to repeat this. If you are going to become a master of the proportion theorem, you must be able to identify a triangle with a line which is parallel to one of its three sides. If you can't see that, you won't be able to do it.
Sorry, because the basis of it is because PQ is parallel to RT.
Yes. Then you can apply the proportion theorem. Yes.
So we ask, when we name our lines, is it that important to put certain points first? Like you wrote CQ and I wrote QC.
Well, it's the same thing.
The same thing, but
Yeah, it's the same thing. If you write CQ like how I did, or QC, it's the same line. It's just that we read it in a different way, but it's the same thing. It's the same line segment. Okay, that's not important, but any teacher should know that CQ is equal to QC. All right. So you should not write even TQ and write that as QT. It's the same. Okay. Are you following? Yeah, but some of you might decide to go for tuition and expect to hear something else. I can assure you, you won't hear anything. It is more than what I'm telling you now. In actual fact, I'm providing you with more information. All right. So CRT, okay? In triangle CRT, that CRT, I'm going to use the proportion theorem because PQ is parallel to RT. Okay? So, like CP over PR is going to be equal to CQ over TQ. Then you write your reason. Okay? Because if you want to get these 3 marks, this is how you do. So there will be 1 mark for the ratio, 1 mark, sorry, this is a statement rather, 1 mark for the reason, 1 mark for the answer. Right? So CP over PR will be 5K over 2K. Okay? Always the constants will cancel out. If you did it right, they will cancel out. So you get 5 over 2. Okay? And you'll be smiling.
So we don't have to say parallel.
No. Because you see, point A, point P, and Q, they are called linear points. So if in this case here, if AQ is parallel to RT, but point A, P, and Q are collinear, it means that PQ is also parallel to RT. There's no way to give them this. Okay. Right, he's there, but you has got a question. Hey, can we have one lesson? She wants to ask something. What? Those are issues. They
It's 5K.
It will be 5K. It's a ratio. 5/2 is a ratio. Well, yes, you write 5K. If you don't know the actual name, then you must write CP is not 5K. But you can't say CP is 5. You can't say that. Because the original name.
So if you let K be 5K,
K is not the
you said K, let K be
Yes. All right. Can I have your attention? Can I have your attention? Can I have your attention? All right. It's regrettable that the first day when I introduced, can I have your attention? When I introduced triangle geometry, the bulk of you were not here. That lesson is very important. I recorded it. You need to go on YouTube and watch it. Okay, in your own time. Because I emphasize to you that you have to know your ratios. You have to know your ratios. Okay? You have to know your ratios. Also, can I have your attention? Can I have your attention? Let me warn you. The moment you decide to not be part of the lesson, especially for maths at this stage, you need to think twice. It should be 50-50. You must ask yourself, am I not going to miss something during that lesson? Don't enjoy just going out. Okay? I'm just letting you know. Because maybe you can miss a concept which might probably have helped you in the near future or in the long term. Okay? All right, let's carry on. Let's come to 8.22. Now, 8.22, I'm going to spend probably the next several minutes just to talk about this question. Like at this stage, okay, I never gave you a question like this. That's why I had to give you this question, so that you have got an exposure of different types of questions on ratios of areas of triangles. Okay? So far I spoke about the formula for calculating the area of a triangle, half base times height, area rule. Okay? Now, for this one now, it's slightly more complex. Now, if you look at the diagram, triangle RCT, this is point R, that's C, that's T. Okay? Then you have triangle ABC, which is the big one. Okay? Do those two triangles share a common vertex? It's not the whole of C. Okay? Well, point C is common to both of them. But in terms of sharing a common vertex, they don't share a common vertex. A common vertex must also have a common angle. Okay? So, listen. Yeah, listen. Your advantage is that I made a video of that lesson. And I sent you a link on the group. Am I right? Didn't I send a link on the group? And I said, please watch this. Okay? On that day, if you missed another subject, there is no teacher who made a video of that lesson. Okay? Be aware of that. There is no teacher who made a video of that lesson. And so, for other subjects, their lesson for that day is gone. For me, it is there. Why you can't make an effort to go and watch? Okay. Look, can I have your attention? Maybe you need to come during your own time. Because I don't have. Yes, you need to come and talk to me one-on-one. All right, I need to carry on.